Okay, this recording is to help you with lesson 4.01, radian and degree measure. Alright, we're going to start out by estimating the angle to the nearest 1/2 radian. I know that a straight line is 3.14 radians, because that would be pi. And when we start dealing with our unit circle more and more in pre-calculus, this will become very familiar to you. But right now we need to know from here to a straight line is 3.14 pi, or 3.14 radians. So if I had to estimate this, I would guess that this is about 3 radians. Now notice that we're going backwards. Usually we go counterclockwise, but now we're going clockwise. Because we're going clockwise, we have to make sure that it is a negative 3 radians. Alright, let's determine the quadrant in which the angle lies. Now, if we were to look at a coordinate plane, we do have 4 quadrants. We have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I just said that if this is 0, I get pi over 2 and pi and 3 pi over 2. So we have to decide where do our radians fall, between what 2 intervals. So pi over 5, that falls between 0 and 2 pi. So pi over 5 is somewhere in the first quadrant. And 7 pi over 5 falls somewhere between pi and 3 pi over 2, so that falls in quadrant 3. Now technically, if you wanted to put everything in decimal form by using your calculator and using the division, you could do that to see exactly where it falls. Right, to find coterminal angles, coterminal angles are angles that are going to appear in the same spot. So basically we want to add 360 degrees or subtract 360 degrees. But here we're talking about radians, not degrees. 2 pi is equivalent to 360 degrees. So we are either going to be adding or subtracting 2 pi each time to find those coterminal angles. So for part A, it already starts with a negative 9 pi over 4. So let's just add 2 pi to that. Well, in order to add 2 pi, let's see, we need a common denominator. So that is the same as 8 pi over 4. So if I wanted to add 2 pi, I could do so and get negative pi over 4. So that could be one coterminal angle. Well, since it's negative, let's add another 2 pi to that, which is 8 pi over 4. When I do that, I get 7 pi over 4. So those are 2 coterminal angles. Now let's look at part B. We have negative 2 pi over 15. If I add 2 pi, let's see, that would be what, 30 pi over 15? So that gives me 28 pi over 15. That's positive. You can keep going and add another 2 pi, but generally we get one positive, one negative coterminal angle. So let's take the 2 pi, or negative 2 pi over 15, and let's subtract the 2 pi this time. So if I subtract it, I get negative 32 pi over 15. So that could be your second coterminal angle, because usually we want one to be positive and one to be negative. All right, now we're going to kind of switch gears. We talked about radians, let's talk about degrees. Estimate the number of degrees in the angle. Well, I know that a right angle looks like that. So half of it, I'm guessing, would be 45 degrees. But again, notice you're going clockwise, not counterclockwise. So because you're moving clockwise, you have to make it negative 45 degrees. All right, determine the quadrant in which the angle lies. Again, it's helpful if you think of your degrees. So 90, 180, 270, and 360. All right, I would make these positive so it's a little easier to look at. Remember, one time around, a circle is 360 degrees. So if I were to add 360, you'd get around 228 degrees. So this is approximately 228 degrees, which does lie in quadrant 3. And then negative 336 plus 360 is about 24 degrees. So 24 degrees lies in quadrant 1. All right, let's convert from radian to degrees or degrees to radians. All right, if we're converting from degrees to radian, we multiply by pi over 180. So we just need to simplify or reduce the 30 over 180. And 30 over 180 reduces to 1/6. So we get pi over 6. In part B, we multiply by pi over 180 and we reduce 150 over 180 to get 5/6. So 5 pi over 6 would be the radian measure for part B. For the next one, we're actually given a formula that S equals R times theta. And S is your arc length and R is your radius. And we want to solve for theta in each case here. So if we know that S is 4 and R is 15, to solve for theta, we have to divide both sides by 15. So theta equals 4/15 radians. And the next one here, this time I know the central angle and I am trying to find the arc length. So let's say we have 15 times 180, but notice that 180 is actually the degree measure, not the radian measure. So I need to convert this to radians. So in order to convert that to radians, let's multiply by that pi over 180. When I do that, I notice I get just pi. So technically you can go 15 times pi to just get 15 pi. And if you want to change that to a decimal answer, you can. It would be 47.12 approximately.